Hello, this is tutorial, and in this video, we are going to discuss about geometric sequences and series. Whether you're taking IB Math AISL, HL, AASL, and HL, this video is right for you. Let's take a look on this number pattern and this one. You can see that from 3 to 6, and then 6 to 12, 12 to 24 is a jump with multiplication. And it is a multiplication by 2 consistently. 6 times 2 is 12. 12 times 2 is 24, etc. For the bottom part, rather than multiplication, what we see here is a division by 5. Or we can say this is also a multiplication of 1 over 5. 10 divided by 5 is 2. 2 divided by 5 is 2 over 5, and then we divide by 5 again, we get 2 over 25, etc. Comparing to the arithmetic sequence, which is the difference by adding or subtracting, in geometric sequence we have ratio, which we get by multiplying or dividing. So if we have a term and then we divide with the term before, we get a ratio. And this is the backbone concept of geometric sequence. We can see that, for example, from the first term to the fourth term, we need 3 jump, which is ratio, ratio, and ratio. So that's why we have the formula. You can take a look at your formula book, in which it is the nth unit is the first unit, and then we multiply with the ratio, and the power is the nth term minus 1. Because let's say if we want the fourth term, it means that the jump is 3 times instead of 4 times. If we want the third term, the jump is 2 times. It is n minus 1. Now we are focusing on geometric series. So we're focusing on the summation of them rather than the exact term. So we can say that A is also U1 or the first unit. And summation of it, it means that we sum from the first unit and then the second unit, the third unit, until the nth unit, right? You have the formula in your formula book. And now let's explore this case so then you know how to derive the formula. So actually, let's say by denoting the sum as the Sn that we want to solve, we know that this is the summation for each term. And because it's all a multiplication of r, we can manipulate them by multiplying r to the both sides. So this is r as n, and this will be ar. We add with ar power 2, we add with ar power 3, we add with ar power 4, and let's say continue it until ar power n minus 1, and then ar power n. In order to make this visually more engaging, we can write it a little bit into the right side. Yep. And actually, because this means continuous symbol, before the ar power n minus 1, we have the ar power n minus 2, because everything is multiplied by r. So because we see a lot of terms are exactly the same, we can remove them by subtracting the first equation with the second equation. So on the left side, I have Sn minus r multiplied by Sn. And then on the right side, because everything is the same from top to down, except the first part from the first equation and the last part from second equation. So I will do a minus a multiplied by r power n. And now we can factor each side and we simplify it. So we get that the formula is a multiplied by 1 minus r power n, and we divide with 1 minus r. In the formula book, you also have the flipped version, in which case it is a r power n minus 1 over r minus 1. So these two will give you the same results. This formula is normally used when the r is between 0 and 1. As for this one, because you're going to subtract with minus 1, It's usually used when the r is above 1. Take a look that we need to have the n here. So this implies that you need to know the exact ending term of which geometric sequence that you're going to sum. So this is a finite geometric series. This is the sample question. You can take a screenshot because I am going to discuss it in 3, 2, 1. So the first part is we need to show that this is a geometric sequence. So again, the backbone is that geometric sequence have a ratio. So how to prove the ratio? Well, we can show that the ratio, the term divided by the term before. So 2 over 3 divided by 2. We can also get it from 6 divided by 2 square root of 3. And we can also get it from 6 square root of 3 divided by 6. And in which it will give you the same result, in which the ratio is square root of 3. So we have successfully proved that the sequence is geometric. We need to find the formula for its general term, which means the geometric sequence, the UN. Okay, so we know that the first unit is 2, and from previously, the r is square root of 3. The nth unit is the first unit, which is 2, multiplied by ratio, power n minus 1. If you want to tidy it further, you can say that the un is 2 multiplied by 3, power the half of n minus 1. For part C, we need to find the 10th term. So we can get it by substituting 10 into the n. So we need u10, or the 10th term, is 2 multiplied by square root of 3, power 9. 10 minus 1 is 9. Remember, to get the 10th term, you jump 9 times. So calculating using GDC, you can get that the answer is 162 square root of 3. Okay, now we need to find the first term that exceeds 1000. So in this case, we want to know the n when the un is above 1000 the first time. So we need to find un first time where it exceeds 1000. So it means that our equation is larger than 1000. So you can find when n is equal to 1000 by putting in numeric solver, or you can put this equation into y1 and you put this equation into y2. Then you visualize them and you know that n is 12.314 ... when it is reaching 1000. So we can say that n must be larger than 12.31 ... if we want that to be higher than 1000. But because we're interested in the first term where this exceeds 1000, right? So the term is a whole number. So when it is 12, it is still below 1000. So the first term is when n is 13. And now because they're interested in the first term, in which u13, we need to substitute back into the formula. So we find the u13, in which the answer is 1458 by substituting 13 into the UN formula. Hope you enjoyed this lesson. If you have mathematics questions or inquiries, you can comment down below and click the link on the description if you want more tutoring.